And we're live. All right. Welcome to another episode of White Paper Wednesday, where I go through a BIP or a white paper or something like that, and just read through it and tell you what it means. Anyway, we have another one that's sort of related to the other ones that I've been reading. I read through BIP 342, 341, and 340 over the past 3 weeks. This one's a little bit shorter. This one is BIP 320, and it was. Really only it was created a couple of years ago, but it's an important part of what's been going on in this space. I think one of the questions I received on Monday is they're getting a warning on their Bitcoin core software saying, 60 of the last 100 blocks have a weird version or something like that. Well, this is this is the reason right here, and we're gonna read through this BIP anyway. BIP 320 is called N version bits for general purpose use, and its author is BTC Drac. And it's a BSD3 clause Creative Commons 1.0 license. Anyway, here are the contents of it. This BIP reserves 16 bits of the block header N version field for general purpose use and removes their meaning for the purpose of version bits soft fork signaling. The keywords must not, require, shall not, should not, recommended, may, and optional in this document are to be interpreted as described in RFC 2119. All right, so basically what it's saying is there's the version field is 4 bytes or 32 bits. Right now, other than the top 3 bits, the other 29 bits are reserved for soft fork signaling as per BIP 8 and BIP 9. This is how SegWit was introduced. It reserved, I think it was bit 2 or the third bit from the right, something like that, in order to signal that for miners to signal that yes, they are ready for SegWit. This one is that's just one of the 29 bits. Another one was BIP 91, BIP 66, I think. There's been several that have used it. Anyway, SegWit is also using one of those bits. But the abstract here is saying we don't need to use all 29 for soft fork signaling. It's going to be rarely the case where we're going to have 29 concurrent soft forks. So as a result, this BIP is reserving 16 of those bits. Now, why would you want to do that? Well, that has to do with overt ASICBoost. Basically, miners can use that version field as additional non-space, and that gives them a lot more room to find the proof of work easier. And a lot of mining equipment now uses ASICBoost because that little bit of hash power that you can get absolutely matters. Anyway, here's the motivation. There are a variety of things that miners may desire to use some of the N version field bits for. However, due to their use to coordinate miner activated soft forks, full node software will generate false warnings about unknown soft forks if those bits are used for non-soft fork signaling purposes. By reserving bits from the N version field for general use, node software can be updated to ignore those bits and therefore will not emit false warnings. Reserving 16 bits for general use leaves enough for 13 parallel soft forks using version bits. So, in other words, there's 29 bits, 16 of them are reserved for miners to use for overt ASICBoost, and the other 13 allow you to still have 13 parallel soft forks going at the same time. We haven't really had more than like 2, so 13 should be plenty. Example uses. The following are example cases that would benefit from using some of the bits from the N version field. This list is not exhaustive. Bitcoin mining hardware currently can exhaust the 32 nonce field in less than 200 milliseconds, requiring the controller to distribute new jobs very frequently to each mining chip, consuming a lot of bandwidth and CPU time. This can be greatly reduced by rolling more bits. Rolling too many bits from end time is not ideal because it may distort the timestamps over a longer period. Version rolling ASICBoost requires 2 bits from the end version field to calculate four-way collisions. Any 2 bits can be used, and mining equipment can negotiate which bits are to be used with mining pools via the Stratum version rolling extension. So this is overt ASICBoost, right? You roll the version, or you tweak a version number so you can find four-way collisions. You can also just use it as a nonce field. So modern equipment is even faster than 200 milliseconds to exhaust the nonce field. But every bit that you add doubles it, right? So, if you add all 16 bits, that's 2 to the 16th more, which is 64,000 times 200 milliseconds. So that's going to be 128,000 million. Well, it can easily go for the entire time for a single thing. So it makes it a lot better, and that's a lot easier to work with. Specification: the 16 bits from the block header end version field, starting from 13 and ending at 28 inclusive, are reserved for general use and removed from BIP8 and BIP9 specifications. So BIP8 and BIP9 say that the top 3 bits are reserved. Basically, everything from 13 to the 4th to last bit are now reserved for this thing. This specification does not reserve specific bits for specific purposes. And there's a reference implementation. Backwards compatibility. Non-upgraded nodes will interpret the reserved bits of this proposal as signals for soft forks and may additionally activate the warning system for unknown soft forks. This proposal does not require soft fork to implement. At the time of writing, no known soft forks are pending using any of 16 bits reserved in this BIP, and given that a non-trivial percentage of the hash rate is already making use of those bits, future soft forks should not utilize those bits for activation signaling. Yeah, so basically that's about it. It's what it does is it reserves 16 bits so that miners can use them for more efficient proof of work finding via version rolling ASICBoost. And I'll have to do some math to figure it out. Let me just do it real quick. 2 to the 16th times 200 is about 13 million. So 13 million milliseconds is 13,000 seconds. That's a lot. 13,000 seconds. That's way more than the 600 on a per block basis. So about the 10-minute interval between blocks. So I mean, you don't even really need to change the Merkle root if you use that, I would think, unless the equipment's that much better, but I don't think it's that many orders of magnitude better. So essentially you could give each mining equipment just like the header and mine it solely on the header and without any regard to anything else. Right now what you have to do is put into regard the Coinbase transaction, and generally you roll bits there in the Coinbase transaction and then recalculate the Merkle root. I don't think you need to do that at all if you do it this way. So that's interesting. Although ASICBoost might be faster because you're pre-calculating like a lot of the SHA-256. So I'm not sure which is faster, but it certainly makes it a lot more efficient. Regardless, very, very interesting thing. If this gets implemented into core, then you won't see those warnings anymore. Anyway, that's about it. It's actually a pretty simple BIP, and I wanted to keep the streak of reading through something on Wednesdays going, so that it's better for me. But yeah, this one isn't a very big one. But if you are curious, you can look at BIP9, which was what activated SegWit, and see how it is that 29 bits are used for soft forks. 16 of those are now being reserved. So That's basically what it is. Yeah, that's about it. Of course, I have my seminars coming up. I have one in Las Vegas next week. I have one in San Francisco in March. I have one in Antwerp in April. If you're interested in this sort of stuff, please apply. It's programmingbitcoin.com. And you can click on the programming blockchain link for all the locations and so on. Yeah, that's what's going to happen. I also have books on Amazon, the Little Bitcoin book and Programming Bitcoin, which you can go to and order. Yeah, and I'll be in Las Vegas next week. Hope all of that helps you. Fiat Delenda Est. This song is done.